Natural Language Processing in Finance, predicting stock market trends using a GRU-based BERT sentiment index. Stock trend prediction has attracted significant attention from the community. This is because reasonably accurate predictions can enable investors to hedge against market risk and generate financial benefits. Conventionally, researchers have relied on numerical data to predict stock trends. However, researchers in recent decades have leveraged textual data to complement numerical data. Researchers have highlighted that market sentiments can affect investor decisions and behaviors, with the potential to drive short-term market fluctuations and cause a disconnect between the stock price and its true value. In this regard, extracting market sentiments from textual data is critical in improving stock trend prediction performances. Vader and TextBlob are commonly used sentiment analysis tools in stock trend prediction problem. Few have leveraged bidirectional encoder representations from transformers, also known as BERT, in stock trend prediction problem. This raises a crucial question. Can BERT be employed to extract market sentiments for stock trend prediction problem? To address the question, this paper introduced a novel sentiment polarity index, GRU-BSI, which is a quantitative measure of market sentiments that were extracted from BERT word embeddings. GRU-BSI, together with historical stock price returns, were fed into a machine learning model to predict stock trend movements. The overall methodology consists of three main phases. In the first phase, we will compute the sentiment polarity score of each text. We will leverage the pre-trained uncased BERT model to obtain the word embedding for the textual data. We'll then pass the word embeddings into the GRU network that were previously trained to distinguish between positive and negative sentiments. The probability of the textual data being labeled as positive will serve as a polarity score of the text data. In phase 2, we will compute the daily value of GRU-BSI. In phase 3, we will feed GRU-BSI and historical stock returns into a machine learning algorithm to predict stock trends. So let us look at the result of the study. We first compared the sentiment polarity scores for selected phrases. This helped us to better understand how different approaches ascribe different sentiments to a number on a sliding scale. We listed the phrases based on human perception of their sentiment polarity. Positive phrases were listed at the top of the list, while negative phrases were placed at the bottom of the list. As seen from the figures, the sentiment polarity scores derived from BERT word embeddings bore close resemblance with the scores assigned manually by a human, despite the presence of slight discrepancies. Next, we proceeded to predict stock trends using machine learning algorithms. In our study, GRU-BSI outperformed Vader and TextBlob, which are well-established sentiment analysis tools, and 3 out of 6 machine learning algorithms utilized for stock trend prediction. The figures show the best MLP and LSTM model for Amazon. The blue line is the baseline model, while the red line is the model with GRU-BSI constructed using social media comments, and we can see that on most occasions, the model with GRU-BSI have outperformed the baseline model. Our results also show that social media comments have stronger predictive power than news headlines. A possible reason is that social media comments generally focus on a specific firm, while news cover a whole range of targets. Thus, news may contain substantial irrelevant information, introducing noise into the prediction model. Lastly, our results suggest that the optimal input window lengths for most of the model lie between 3 and 6. This is in line with the findings of other researchers who exerted that the impact of events or sentiments on the stock market may last for more than a day. To sum up, we live in a world increasingly characterized by complexity and volatility. Stock markets are constantly rocked by disruptive current events. Predicting stock trends using mere quantitative indicators or numerical data derived from actual stock market movement is no longer adequate. Qualitative factors or textual data that can capture real-life events and sentiments are required to complement quantitative measures. BERT word embedding, which has tremendous potential to represent market sentiments accurately, may be a viable technique to enhance prediction performances.